De Moivre's theorem and nth roots. So this is where we get to talk about now. We had the vectors, we had the complex numbers, right? And we had the polar coordinates. So we're going to now mix and match these together. Okay. So it's a little bit of juggling is going to be required here. So we'll talk about this. Talk about the complex plane first. So we're in the complex plane. We have the real axis, and we have the imaginary axis. So if I had 3 plus 4i, it would be 3 and 4, like that, right? 3 plus 4i. So, and then say I had another one that was 1 minus 2i, so it'd be 1 minus 2i. Now can you see if I add these two together, how would I add them together? If I add these two together, what do I get? 4 and 2i, right? 4 plus 2. Because basically I'm taking these two and these two, 4 plus 2i, correct? Let's think of this as a, so where we're at. So we're gonna end up with 4 and 2i, right? Now let's think of this in the vector plane. So the corresponding vector to this would be that. This guy here, right? And then I would add this vector. And I'm going to do the same exact mechanics that I just did, right? I'm going to take the x's together, I'm going to take the y's together, right? So I'm going to end up with 4 and 2y. Or, if you want to look at it this way, it would be this vector plus this vector added together, right? Remember doing this? The head to tail, right? Or head to tail to get to the end, right? Remember doing this in the vector plane? Well, we did this, right? So it's kind of the same thing. So you can see that there's a direct correlation between the two, right? Okay. Direct correlation to the two, plus, we talk about this in vectors, can you see that this is, if I call this guy theta 1, and this guy theta 2, can you see that this guy here is going to be what did I just do? 5 is the magnitude, right? Yeah. 3 plus 3 squared plus 4 squared is 9 plus 16. 25 squared of 25 is 5. Theta 1, so if I took this guy, and I'm just decomposing it to x and y's, correct? Right? And I could do the corresponding thing over here too, right? What's my magnitude? Root 5, right? So I'm going to go root 5, and 1 over root 5, negative 2 root 5, and I would find the corresponding theta 2. I could find that, right, using the tangent and whatever. I'm not going to get into that, but I could do that, correct? Can you see how I can use these in polar form? Because these are polar forms, right? Yeah. Polar forms. I'm using this in polar form to do this whole thing. Okay, so this is where it becomes kind of dicey. Okay, so now I am taking this guy and putting it into polar form. Okay, putting it into polar form. So if you go to page 503, okay, it talks about how to add those two numbers together. Okay, we already did that. Flip the page. go to page 504. Absolute value or the modulus of a complex number. So a complex number, 3 to 4, 3 plus 4i, has a modulus of 5, which is basically the magnitude of this vector. If you think of it as a vector, it's a magnitude. So instead of calling it magnitude, in the complex they call it the modulus, the absolute value, the modulus. If you can look at there, the modulus is nothing more than square root of a squared plus b squared, just like we talked about. Okay? And then the theta, if you go down to page 504, I have not talked about this yet, but if you go down to page 504, the theta is actually called the, what does it call it? The bottom blue box.
Argument?
The argument. Oof. They're pretty fancy words here. So we have a modulus, right? And then we have an argument. So finding the polar form. So let's see if we can do the finding the polar form there. 1 minus root 3i. So if we had 1 minus root 3i, so that would be what? 1 minus root 3i. So it's going to be somewhere down here, I would think, right? So what would be the argument? Not the argument, the modulus. 2 or 4? One of them's right.
2. It's 4.
Maybe 2, right? Because this squared plus this squared, you add this squared plus this squared, and then you take the square root of that.
So that's 4.
Square root of 4.
1 plus 3 is 4.
2.
Square root of that is
so
2.
the argument would be 2, right? The argument would be 2. So I pulled the 2 out. This is basically this, correct? Right? So I need an angle that gives me a cosine value of this, sine value of this, right? Cosine and sine.
Yeah.
Cosine and sine. Cosine and sine. So what is cosine gives me? So I'm basically have to be in the 4th quadrant, which I am, right? I'm in the 4th quadrant because this is positive, this is negative, right? So what's my angle?
5 pi over
No. You're thinking the right way.
5 pi over 3.
5 pi over 3, right? 5 pi over 3, right? It's 5 pi over 3.
Yeah.
So you're in the polar coordinates. It's going to be 2 and 5 pi over 3. Can you see that?
Yes.
Right. Whereas this is called the modulus. Called the argument. Modulus argument. Okay. Let's go to B, and B I have -3 and -4.
That one's easy.
Okay, so what's the magnitude here? 5. So I'm looking for an angle that gives me the cosine value of this, sine value of this. Cosine and sine are both negative, therefore it's going to be in the 3rd quadrant, which it should be, right? -3 and -4, we're down here, right? So I have to find this angle, correct? Somebody want to find that angle for me? What would the angle be? Am I using, what am I, how am I going to figure this out? How am I going to find the angle out? Yeah, so you want this in degrees, right? Obviously. This should be in degrees, right? Do it in degrees. So you're not going to get a pi argument here.
I got 233.1.
233.1 degrees. How did you find that out?
I did cosine inverse of 3.
So you did the arc cosine, you did the arc cosine, is that what you did?
Yeah, 3 over
Theta is equal to arc cosine of, what's the cosine value of this guy here? You did this? This is what you did?
I did 3 over 5 and then just added 180.
Okay, so 3 over 5. See what he's doing here? he's finding this guy up here, right? And then add 180 on top of that. Right?
Yeah.
And what did you get? 233?
233.
233. So you're gonna get 233.1, right? Again, modulus argument. So the point really, so you should be thinking by now, okay, I get this. I kind of get this. I understand why we're taking these guys and making it into look like this. But what's the point? What do I actually gain by doing this? Right? There has to be some sort of advantage of doing this, right? Because if I'm trying to do this operation, and you want me to go through this for both of these, I'm not gaining anything. I would much rather just do this and be done with it, right? There is no point in going and doing this. Okay? The advantage that you get by doing this is when you are asked to, okay, so let's say, what was the other one that I did here? Was 1 and negative 3, right? So it was 1 and negative root 3i, right? And this one was 2 and 5 pi over 3, which is what? 5 pi over 3 is, if I go in, what do I get in degrees? What is 5 pi over 3?
300.
300 degrees, right? So this is what I get, right? This is equal to this. Right? The advantage is this. The advantage is when you're asked to do this. Okay. Or if you are asked to do this. Okay. This is not too bad, right? If you're asked to multiply, you just multiply it out, right? And then you get, what, 3 minus 6i, and I go this way, I get plus 4i. This time this is negative 8, but I squared is negative 1, so it becomes plus 8. So I'm going to get 11 minus 2i. Right? Okay. This is a little problematic, right? To say the least, right? Does anybody remember how we did this?
Yeah, the VT is long.
No. You're going to multiply top and bottom by the conjugate of this guy.
Yeah.
So this becomes 1 minus 4i squared, but minus I squared is, so it's become 1 plus 4 becomes 5, right? So the bottom becomes 5. Then I have to do all this out. I'm not going to go ahead and do it, but you can see how this is pretty elaborate, right? There's a lot of steps involved with this. Okay. Go to page 505. Multiplication and division of complex numbers. Read the blue box. Read the blue box, and be awed and thinking, so now what it is if I have 1 and negative 3, and I'm going to ask you, if you ask me to multiply this by this guy here, which will have negative 3 and negative 4, I merely take 2 and the 5, multiply them together, get 10. I add these two together to get 533.1 degrees. That's it. If you think this was easy, what about the division? If you look at the division, it becomes even more so, right? Because now what you're telling me is that I can do 1 negative root 3 divided by negative 3 negative 4. I can go, well, this is nothing more than this. And then I take from this guy, subtract this guy out. I'm going to get what? 66.9. Whoa. You see how simple that is? This is why we do this. This is why we go through all this stuff and trying to go from this kind of notation to this kind of notation, this notation to this notation, because I can do this in one fell swoop. Okay? This is the advantage that you get. Right? So if you go to example number 3, let's go to example number 3. Example number 3. I have Z1 and Z2, where Z1, not I meant 1, is equal to 25 root 2 cosine negative pi over 4, I sine negative pi over 4. C2 is equal to 14 cosine pi over 3, I sine pi over 3. And it asks me to find what, Z1 times Z2. So Z1 times Z2 is nothing more than this times this, which is 350 root 2. And cosine, I add these two together, what do I get? Done. Okay. Right. See how simple that was. Just go ahead and multiply these two together, add these two together. That's it. Okay. Division, I'm lazy, so I'm just gonna go ahead and divide this guy right here. Z1, Z2 is equal to 25 root 2 divided by 4t, and I'm gonna get cosine this minus this, right? So I'm gonna get negative 7 pi over 12, I sine negative 7 pi over 12. Okay? This minus this, right? So it's going to be negative pi over 4 minus pi over 3. That's how I got that. Right? And we'll stop right here. Okay, we'll do the powers of the complex numbers tomorrow. And